Hi everyone, welcome to the presentation on the topic controlled rod driving mechanism, particularly focusing on the electrical side of the CRDM. When we are looking into the CRDM, what is the purpose? It is used for controlling the actions of RCCA, Road Control Cluster Assembly. Or commonly, the CRDM is situated on the top of this RCCA. The major role of the CRDM, there are three major roles. One is the regulating the nuclear fission. Second one is controlling the reactor power output. And last and third one is ensuring the safety operation of the reactor. These are the major role or the major contribution of this CRDM. Then we can look into the parts of the CRDM. There are five components in this CRDM. First one is the main component is control rods. Second one is CRDM, the driving mechanism. Third one is electromagnetic coils. Fourth one is latching mechanism, and last one is the guide tubes. These are the five major components of the CRDM. We can look into the electrical side. In CRDM, for the operation of CRDM, the electrical supply is required. For that, we are providing a motor generator set. Why we are using a motor generator set for supply the electrical energy to the CRDM? You can see in the architecture, after motor generator set, we are providing some trip breakers and also bypass breakers for supplying this electrical energy to the CRDM. By providing the electrical supply using motor generator set, it provides consistent and quality electrical supply for the CRDM. It acts like an isolated source of supply, because if there is any disturbance or any fluctuations in the preferred power supply to the reactor, to the power plant, it will not affect to this supply, because the supply is isolated from the common supply. It's a great advantage or a great safety option for supplying the electrical energy to the CRDA. After this motor generator set, we are providing these trip breakers, because when we are in a danger situation, if anything happens like an accident situation or anything happens, any abnormal occurrence events happened, we have to immediately shut down the reactor, that is scram, we have to shut down the reactor. So for that purpose, we are just tripping the breakers, so the electrical supply to the whole coils will be deactivated. Immediately the controls rods will be inserted. The action of the CRDM is to insert or to withdraw the control rods, so that the controlling of the power, the reaction and the safety of the reactor happens. We can move into the main parts of the CRDM. There is electromagnetic drive mechanism. In this, the electromagnetic coils are used for the precise movements of the control rod actions. In this, we are providing three coils, electromagnetic coils. The names are, one is moving coil, other one is stationary coil or the holding coil, and third one is lifting coil. Three coils are providing these movements of the RCCA. So as the name indicates, it provides moving, holding and lifting. That's why the part of the moving. These three coils plus rod drive shaft provides the movement and also the stationary station of the RCCA. In this, the important the part is the latching mechanism. The latching mechanism ensures the precise movement or the precise control of the RCCA. So when one of the RCCA or any RCCA have to move, then the coil will energize or de-energize accordingly. The holding coil will always hold the RCCA. The electromagnetic force, it's a huge force. It's that much enough to hold the rod in that particular position. It will control the RCCA at that at that position without moving. That's the important thing. The RCCA should not be moved in any case. If any vibration happens, if any abnormal condition, also the RCCA should be within the control of these coils. In this, as we have seen in the architecture, the supply for these coils are coming from a rod control power cabinet. This rod control power cabinet converts the AC into pulsating DC. This DC energy is supplied to these coils. So these coils are energizing. The energizing sequence depends upon the actions to be done on the rod control assembly. The inserting and withdrawing of RCCA controls the action or the reactivity of the reactor. Hence, the CRDM efficiently controls the whole movements of the RCCA. For that, there is a power supply unit, that is rod control power cabinet. For the proper action of the CRDM, the energizing sequence of the coils should be accurate. For that, there is a part that's called the brain of the CRDM, that is rod control logic cabinet. This rod control logic cabinets gives the signals, especially the group signals, current order signals that are giving from this rod control logic cabinet to the rod control power cabinet, where from the DC supply to the coils is giving. So the rod control logic cabinet is the brain of the CRDM that controls or that decides how much the RCCA should be moved, or which RCCA should be moved, or the direction and also the speed of the RCCA. The whole important parameters are the decision from the rod control logic cabinet. During normal operations, the movement of the RCCA are purely depending upon the process instrumentation control signals. Depending upon these parameters or the control and instrumentation, process control instrumentation signals, the CRDM acts. For that, lift coil and associated armature provides the action to move the RCCA. The movement we call as step. One step is almost 10 mm. The full distance a control rod can move is about 4110 mm. In this, one step is 10 mm. For each step, the lift coil and related armature will provide the motion. So the rod control logic cabinets controls the whole CRDM action. That's why it's called the brain of the CRDM. The time is a major concern for these operations. For one step, all the actions should be within the limit of 0.7 second. In case of scram, the shutdown, we normally say it as up to 2 seconds or maximum 3 seconds. Within 3 seconds, the whole RCCA should be inserted. That is in case of any abnormal accident or any other design based accident cases also. The shutdown, the whole operation should be within 2 to 3 seconds. Here, the trip mechanism will provide the tripping of the supply within time. Then the whole coils will be deactivated. Then the RCCA by the gravitational force within 1 to 2 seconds will be inserted into the reactor fully. As we have already discussed, the control rod logic cabinet, the signals always receiving from the process control instrumentation side. The parameter, the process control always measuring or monitoring the parameters like pressure, temperature, reactive power, flow of water, and so on. So as per these signals, as per these inputs, the control rod logic cabinets operates. For the CRDM, there are two types of modes for the operation. One is manual and second one is automatic. At the starting period, up to the 15 percentage of the full power, when the reactor is starting, the CRDM action will be in the manual mode. Manual mode means it's fully controlled from the main control room by the action of the operator. He will decide the action of the CRDM for the concern of the safety during the starting time. We set the CRDM in manual operation up to 15%. After attaining 15% of the full power of the reactor, the mode of operation of CRDM will be manually changed to the automatic mode. After that, the operation of this CRDM fully depend on the process control instrumentation. From the process control instrumentation, the signals will come to the logic cabinet, rod control logic cabinet. Then this rod control logic cabinet will give the signals to the rod control power cabinet, where the DC supply that is converted from the AC are going to the CRDM coils. These coils are controlling the actions of the RCCA. This is the overall picture of the CRDM, particularly focusing on the electrical side from an electrical engineer. I know there are many more details to deep dive in this topic, because CRDM is a crucial and very important topic and other part of the reactor. But now I am concluding this presentation. Thank you for watching. Goodbye.